It didn't make the headlines, but it should have. On February 17th, 2024, NASA detected an unusually powerful solar flare, classified as X9.6, the strongest in over a decade. And it was aimed almost directly at Earth. The live stream cut off. The data feed went silent. And since then, NASA hasn't said a word. Scientists call it the Killshot, a solar storm so powerful it could fry satellites, collapse power grids, and erase the internet in seconds. Not in a science fiction movie. Not a doomsday theory. A real documented threat, confirmed by NASA, the European Space Agency, and multiple national defense agencies. When the last solar storm of this scale hit in 1859, telegraph wires caught fire, compasses spun uncontrollably, and the sky lit up blood red, as far south as Colombia. But that was a world without satellites, without planes, without internet. Imagine that kind of storm. Today. So why aren't we ready? Why is no one talking about this? And what exactly did NASA detect that day that made them go silent? Most people think of a solar storm as something far away, something space weather scientists deal with. But here's what happens, step by step, when a big one hits. It begins with a solar flare, a massive eruption of electromagnetic radiation from the sun's surface. Sometimes that flare is accompanied by a coronal mass ejection, or CME. Billions of tons of plasma hurled into space at millions of kilometers per hour. And if that CME is headed toward Earth, we get just 17 to 48 hours of warning, if we're lucky. When it reaches us, the first thing it slams into is our magnetosphere, the invisible magnetic field protecting the planet. Usually, that field absorbs the impact, channeling energy toward the poles. That's what creates auroras. But if the CME is strong enough, like an X-class superflare, the magnetosphere doesn't deflect it. It collapses, just for a moment. But in that moment, Earth becomes exposed. The solar particles penetrate the atmosphere. They overload power grids. They knock out transformers. They fry satellite circuits. Let's walk through what that looks like in real time. Minute 1. Air traffic control loses all high-frequency communication. Planes flying over oceans have no contact with the ground. Minute 3. GPS signals fail. Thousands of commercial planes, cargo ships, and autonomous systems go blind. Minute 6. Satellites begin to shut down, from Starlink to weather, navigation to military. The Space Force can't even track what's failing. Minute 9. Power substations overload. Transformers explode. Entire cities begin to black out, not just one or two, but hundreds. Minute 15. The financial system grinds to a halt. Bank servers go offline. ATMs stop. Credit card networks freeze. Hour 1. Hospitals switch to backup generators. Mobile networks collapse. The internet goes silent. Hour 4. Nuclear plants begin emergency cooling operations. Trains stop. Water pumps fail. And that's just the first day. Governments have no global plan for this scenario. In the U.S., the Department of Homeland Security admits that a severe solar storm could take down the grid for weeks. The North American Electric Reliability Corporation, NERC, estimates it could take months to restore full power. And here's the truly terrifying part. If just 9 key transformers in the U.S. are destroyed, the grid collapses for the entire continent. Those transformers, they're custom-built. They take 12 to 18 months to replace. And we don't stockpile spares. Now imagine it's not just the U.S., but Europe, Asia, everywhere. No power, no internet, no refrigeration, no supply chains, no government coordination, no information. Modern civilization is built on electrons. A solar storm is a global eraser. It doesn't matter who you are, rich or poor, rural or urban. If you're on Earth, you're in range. And yet, most of the world remains dangerously unaware. But history already warned us. In Part 3, we'll look back at the Carrington Event of 1859, a solar storm so powerful it shocked the planet before the digital age. And why? If it happened today, it wouldn't just knock out telegrams. It would knock us back a century. It was September 1st, 1859. Just before dawn, British astronomer Richard Carrington was sketching sunspots from his telescope when a sudden flash of light blinded his lens. 24 hours later, the Earth was on fire. Not literally, but the sky lit up in ways no one had ever seen before. Across the world, auroras stretched from the Arctic all the way down to the Caribbean. People in Cuba and Colombia described the night sky glowing blood red. Miners in Colorado thought it was morning and began making breakfast. Ships lost navigation as compasses spun uncontrollably. Telegraph stations, the 19th century's only global communication system, began to spark, overload, and ignite fires. Some operators were shocked through their hands. Others kept transmitting even with the batteries disconnected. The geomagnetic energy itself powered the lines. That's how strong the storm was. And remember, this was a world with no power grid, no internet, no satellites, no modern infrastructure. Imagine that same storm hitting today. We call it the Carrington Event. NASA estimates it was a Class X-45 solar flare, more than 10 times stronger than anything we've recorded in the last 2 decades. If that storm hit now, experts estimate it would cause over $2 trillion in damage in just the first week. And the ripple effect? Stock markets collapse. Global shipping halts. Emergency response systems fail. Entire countries go dark. Not for hours, not for days, but for months. Here's something even more unsettling. We already had a near miss. In July 2012, a CME almost as powerful as the Carrington Event did erupt from the sun. But it missed Earth by just 9 days. NASA's Daniel Baker later said, "If it had hit, we would still be picking up the pieces." It was pure luck. Nothing else. And that was over a decade ago. Today we have more satellites, more dependencies, more targets. The Carrington Event isn't just history, it's a preview. Now here's the twist most people don't know. Recent ice core samples from Greenland and Antarctica show evidence of even larger solar storms, thousands of years ago. Some of them 10 to 20 times stronger than Carrington, long before we had telescopes, before we could even write them down. The sun has done this before, and it will do it again. The only question is, will we survive the next one? In Part 4, we stop theorizing and simulate what a modern-day Carrington-level event would look like, second by second, country by country, system by system. If you think you're safe just because your phone still works, think again. Let's say it happens tonight. 3:13 a.m. GMT. A massive coronal mass ejection leaves the sun, aimed directly at Earth. The alert goes out, but the warning time is short. Just 15 hours before impact. T-minus 15 hours, NASA's Solar Dynamics Observatory registers the blast. The Space Weather Prediction Center issues an alert, but most people never hear it. It's buried under sports scores and celebrity gossip. Only a few countries begin emergency shutdown protocols. T-minus 10 hours. Power grid operators scramble. Some switch to safe mode. Satellites begin reorienting to protect their panels. But not all of them are built to withstand what's coming. Planes stay in the air. Hospitals continue running delicate equipment. Everyone assumes it'll be fine. T0. Impact. A wall of charged particles slams into Earth's magnetosphere. The auroras begin, beautiful at first. Sky turns green in Paris, purple in Florida, blood red in Beijing. Then, everything starts to fail. Minute 1. High-frequency radio bands collapse. Military loses comms. Air traffic control goes silent over oceans. Minute 5. GPS satellites short-circuit. Thousands of ships and planes lose navigation. Minute 10. Massive transformers in North America and Europe begin to overheat. They were never designed for this. Minute 20. Cell towers crash. Credit card machines freeze. Banks go offline. Hour 1. Entire cities lose power. Hospitals go dark. Emergency generators activate but only last for hours. 911 lines are flooded. Response time? Infinite. Hour 3. The stock market halts. The internet splinters. Not just slow, but gone. Starlink? Overloaded. Google Cloud? Offline. Hour 6. Backup systems fail. Water treatment plants stop. Sewage spills into rivers. Supermarkets begin closing. Digital locks malfunction. Hour 12. Every modern convenience is now dead. No refrigeration, no phone, no lights, no heat, no gas, no coordination. This is day 1. And this is still assuming it wasn't a direct hit Class 10 flare. Here's the part most people don't understand. We can't just flip the switch back on. Transformers take months to build. The parts? Custom. Made overseas. The logistics? Now paralyzed. Experts estimate that a continent-wide blackout could last between 4 to 18 months depending on supply chains. And with no internet, no fuel, no electricity, society begins to fracture. City centers will collapse first, then food systems, then trust. Because no government can prepare for everything failing at once. This is not science fiction. It's not hypothetical. It's happened before, and it nearly happened again in 2012. And guess what? The sun is entering a more active phase than it was back then. In Part 5, we'll look at the latest warnings, not from tabloids, but from NASA. Internal memos, satellite reconfigurations, budget surges in space weather defense. Why? Because they know what's coming. The question is, do we? NASA hasn't made any bold announcements. No televised press conferences, no doomsday countdowns. But if you look closely, their actions speak louder than anything they've said. In mid-2023, NASA increased funding for the Solar Dynamics Observatory and the Parker Solar Probe by nearly 40%. No formal explanation was given, but internal procurement reports show emergency contracts for hardened satellite shielding, deep space communication relays, and rapid deploy replacement sensors. All for one reason: to maintain eyes on the sun, no matter what. Then came the reconfigurations. In January 2024, the Deep Space Network quietly repositioned 2 of its most powerful dishes. Not toward Mars, not toward Voyager, but toward the solar corona. And in March, an email chain leaked from the Jet Propulsion Laboratory. Subject line: Solar Max Planning, Blackout Probability Tiers. It included phrases like grid-level threat thresholds, magnetospheric breach window, telecom hardening fallback procedures. This wasn't a simulation. It was a contingency plan. But here's what raised even more eyebrows. NASA submitted a closed-door advisory to the U.S. Senate Subcommittee on Space and Science. The subject was redacted. But after FOIA, Freedom of Information Act, requests, one phrase became visible. A Carrington-class event is no longer hypothetical within this cycle. That's not conspiracy. That's on record. Yet the public knows nothing. Why? Because panic breaks systems faster than storms. Imagine if everyone suddenly realized that with one solar flare, everything they rely on, every app, every call, every plane, every paycheck, could disappear overnight. Governments rely on stability, and if that means silence, they'll choose silence. Now, here's something you haven't heard in the news. In October 2023, two commercial satellites lost telemetry while passing over the South Atlantic anomaly. The incident lasted just 18 minutes, but the particle energy spikes recorded were off the charts. When independent analysts tried to publish the readings, their data sets were removed from public archives within 72 hours. The only explanation? Radiation calibration error. But those same energy spikes matched a forecasted CME event that never officially arrived. So what happened to it? Where did it go? Or worse, did it hit something, and we were just never told? Let's be clear. NASA is not evil. They are not lying to destroy, but they are withholding information to delay chaos. It's a strategy as old as institutions themselves. Control the signal, contain the panic. But in that silence, we're left exposed. And the storm doesn't care about public relations. In Part 6, we look at what ancient civilizations may have witnessed, and why some believe solar storms were responsible for entire societal collapses. Sound far-fetched? Just wait until you see what they carved into stone. Before telescopes, before satellites, before science could explain the sun, ancient civilizations looked up and told stories. But what if those stories weren't fiction? Around 12,000 years ago, something strange happened. Multiple civilizations, across continents, recorded an era they called the burning sky. In Mesopotamia, it was the god Shamash, angry and blazing. In Hindu texts, Surya scorched the land for days. The Norse described a sun wolf devouring the skies. And in pre-Columbian Peru, the sky cracked open and rained fire. Across the world, petroglyphs and carvings appear, eerily similar. Circular bursts with radiating lines, spirals descending from sky to earth, human figures shielding their eyes from overhead light. These aren't just art. They may be records. In 2017, a study of ice core samples from Greenland revealed a massive spike in cosmic radiation, dated to around 774 AD. This event, now called the Miyake Event, left its fingerprint in tree rings and polar ice across the globe. But no solar flare was ever recorded that year. Why? Because it happened before telescopes. And yet, the effects were global. Japanese scrolls from that year speak of a red sky that danced for nights. Irish monks wrote about celestial fire raining from the heavens. Aboriginal Australians told of the sky splitting open. Different languages, same story. Now here's the pattern. Every 1,000 to 1,500 years, Earth is hit by a high radiation event that we don't see coming. And every time, cultures fracture. Collapse doesn't happen instantly. It happens in the aftermath. Failed crops, navigation breakdown, mass migration, panic, conflict. Historians blame war, famine, politics. But what if the true trigger came from above? Let's ask a harder question. Why do so many ancient temples, monuments, and altars, from Egypt to Mesoamerica, align so precisely with solar events? The solstice, the zenith, the death and rebirth of the sun. Was it reverence or fear? The Temple of Hathor in Egypt shows artwork of the sky pouring fire. The Nazca lines in Peru include spiral shapes and solar bursts visible only from above. The ancestral Puebloans carved concentric sunburst rings into canyon walls, exactly at solar declination angles. Coincidence? Or were they trying to leave a warning? If ancient civilizations recorded the sun's wrath, and modern science is just now catching up, subscribe for the truths they tried to preserve in stone, and that NASA won't say out loud. And maybe the scariest part? These carvings often end suddenly. Whole cities abandoned, scripts unfinished, walls left half-carved, as if something stopped them. What could make an entire civilization walk away from their own legacy? In Part 7, we face the uncomfortable truth. The sun is not our enemy, but it doesn't care if we're watching. And when it acts again, we won't be the first to fall. The sun isn't angry. It doesn't hate us. It doesn't even know we exist. But it can end us, without meaning to. And maybe that's the most terrifying part. For centuries, we looked up and worshipped the sun. Then we tried to measure it, model it, predict it, and somewhere along the way, we convinced ourselves that we'd tamed it. But the truth is far more humbling. We've built our entire civilization on top of a magnetic bubble, a thin shield of atmosphere and luck. Our power grids, never designed for solar storms, our satellites, floating targets, our lives, streamed, stored, connected, but not protected. We are not the strong ones in this story. We are not the survivors. We are the exposed. And the irony? We built all of it. The satellites, the towers, the cloud servers, the digital locks, the code, the current, the clock. We didn't just build civilization. We built its Achilles heel. Pause for a moment and look around you. That phone, that screen, that Wi-Fi router, that smart fridge, that self-driving car, that smart city. All of it depends on uninterrupted energy. And one solar storm, just one, can break it faster than war, faster than AI, faster than any virus. Not because the sun is evil, but because we forgot to respect it. This is the mirror point in our story, the part where we stop pointing fingers outward and start looking inward. Because the sun will keep flaring. It has for 4.6 billion years. It owes us nothing. But we built a world that cannot survive without power for more than 72 hours. That's not nature's fault. That's ours. So maybe the question isn't, what happens if a solar storm hits? Maybe the real question is, why did we build a civilization so fragile that one pulse of plasma could erase it? We call ourselves advanced, but no species is advanced, It can't last a week in the dark. In Part 8, the final part, we'll talk about what you can do, what governments should do, and why the clock is ticking, even if no one's watching the sky. Because the sun doesn't care if we're ready. It only cares that we're in the way. The question was never if, it was always when. And now, that when might already be in motion. In July 2025, the sun entered Solar Cycle 25's peak phase. We're seeing more sunspots, more flares, and stronger CMEs than anticipated. NASA once called this cycle moderate. They've since revised that assessment. privately. The Parker Solar Probe is now transmitting from within 5 million miles of the Sun's surface, closer than any object before it. Its mission? To understand the mechanics behind these eruptions. But here's the real truth. We're not researching to prevent them. We're just hoping to see them coming. So what now? What can any of us do when faced with something cosmic? Surprisingly, more than you think. What individuals can do? Keep a solar alert app. NASA, NOAA, and independent networks track space weather in real time. Understand the risks of grid collapse, not to panic, but to prepare. Keep offline backups of essential data, emergency radios, flashlights, water filtration, basic communication methods. This isn't prepping. It's acknowledging reality. What governments should do: harden transformers, stockpile backup units, update grid infrastructure to withstand G5 class geomagnetic events, train the public, not with fear, but with clarity. Invest in deep space solar monitoring. Create international cooperation on space weather response. We prepare for earthquakes. We prepare for hurricanes. Why not solar storms? Because here's what we've learned. The sun doesn't care about borders, or ideologies, or GDP, or who's in office. It flares, mows, and we all face the consequences. The Carrington Event was 166 years ago. The Miyake Event, 1,200 years. Statistically speaking, we're due. And with every day we don't prepare, we give the next flare just a little more power. Imagine, you're scrolling through your phone, the screen glitches, the lights flicker, then fade, then silence. The countdown already started. We just didn't know we were in it. So now we ask, if the sun erased everything tomorrow, what part of us would still remain? This is AstroMystery. We ask the questions no one else will, and we shine a light where others look away. The sun is watching. But the real question is, are we?